C# has had varying support for null and nullable types throughout its history. So I just have a couple of slides here to go over the history. And starting with 1.0, there was no support for nullable types. There was no such thing. There was a null reference. There was a keyword null, and there were reference types which could be assigned null. Value types could not be. And if you needed a reference to a value type, the best you could do was to box it, as far as I remember, which we won't cover because it's hardly a thing anymore, I think. Probably starting with 2 because it had generics. But another thing we got in C# 2 were nullable types. And this means we could add a question mark at the end of a type declaration and mean that that type could be nullable. Now, this didn't make any sense on reference types because they were already had the ability to be assigned null. So this really was only useful for value types. So your ints would get it, a lot of other things would get it. String was an exception. It could already be assigned null. And so you wouldn't have a question mark on a string type either. But every other reference type could already be null, so you couldn't make those nullable as well.
So
or maybe you could, but you just never did.
In this context, were strings considered a value type? Even though they're
strings are a special type.
Strings are, that's exactly the name of the slide. They're a special type. Okay. They are immutable and they are reference types, but they have some value type behaviors.
That's what I thought.
And that's the case in every language, it seems. Strings have to be given special consideration. So,
except for C.
Except for C. I was just going to say, in C, there's no special case. They suck no matter what.
Yeah, you can't do much with them.
Yeah.
You need a type library to handle them.
Yeah. Okay, so in 8, it got really magical. Nullable type reference types appear, and that's primarily what we're going to talk about here. That means that you can make reference types nullable with the question mark, as well as value types, and as far as I know, every type. The problem that you're going to run into is now you need special ways to code around that. But the purpose for it we're going to cover in a little bit, because there's good reason for it. So I want to point out that the nullable reference types are enabled by default in .NET 6, but .NET 6 is not C# 8. So if you have a version from C# 8 that I forget what that was, 3.0, Core 3, the point that I'm making here is if you have C# 8, whichever version that is, but it's less than .NET 6, this will probably not be enabled by default. So you need to pay attention to the future slides here to deal with it. Yeah. So in C# 9 we get record types, and those of course can be, there are 2 types of records. One's a value type and one's a reference type, and they can both be made nullable. I just threw this slide in there because I encountered it, and I don't know anything about it. I couldn't find anything more about it except one post about this bang bang operator. And they showed that you could put it on a parameter, but as far as I know, it didn't make it into the release. And I don't remember seeing it in the beta.
Because I don't think it needs it.
It's kind of weird to look at and figure out what exactly you're getting out of it. You get a null reference exception if it violates this rule, but if you don't have that operator and you try to dereference the thing, you get a null reference exception anyway. So I just don't understand its purpose in life. Let's talk about the $1 billion mistake. So Tony Hoare, who is not a prostitute, is a really cool guy who was, as you can see on the right, an achiever of all manner of really astounding things. So he's a knight. He is Sir Tony Hoare. He was tapped on the shoulder by the sword wielded by Her Majesty the Queen of England, etc. The whole university scene wishes he was theirs. And then down toward the end, we have the bullet point that says he apologized in 2009 for single-handedly destroying computer science as we know it. So let's talk about that. And that's literally what he did. He apologized for this. He said he invented the null reference, and it caused more bugs and software failures than anything else, and it has probably caused $1 billion in damage over the years, and he calls it his $1 billion mistake. He did this, it's not on the slide, but just for fun. This was part of his work on a language called Algol W in 1965. If he hadn't invented it, somebody else probably would have at some point.
Undoubtedly.
And he said he didn't really want it in there, but he couldn't resist because it was just so easy to throw it in with the rest. So somebody surely would have done it at some point. Probably a Java guy. Many new programming languages you'll find, like Rust, I knew off the top of my head. The rest of these I just kind of didn't realize, but Rust was designed from the ground up with, among other things, issues with the null reference issue in mind. It doesn't really even allow it to be an issue. It's sort of like these new features in C#. If you look down the list, they all kind of solve it in the same way, or very similar ways. So if you're familiar with any of those languages, this will come naturally to you, and vice versa. So I've got a sentence down at the bottom, and I don't know if I really am committed to this statement or not, but I wanted to have a statement here that just kind of spells out what we're trying to do here. And so it might be a good discussion point. I've written, the solution to the problem is to never allow a null reference type to be null, a reference type to be null without the compiler being able to check for it. That is that's not the one, the latest version of that, I don't think. I meant to say it should never be allowed to be null unless you intended it, and the compiler should be able to verify that. So there are instances where you might still use null, but you want the compiler to be able to tell you if that's doing what you intended. So we have to give the compiler these hints so that it can do that. And technically the compiler that we're talking about is really a static analyzer that's in use by Roslyn. So it's not so much the compiler itself, but the static analyzer. And what that means is that your IDE can do those checks for you and give you squiggly lines to tell you when you're screwing up. Those squiggly lines, of course, are linked to warnings in the compiler output. And so what we're dealing with are hints, warnings, and errors in the output of the compiler.
Before it runs.
As it runs. Before the program runs,
Before
yes.
the program
As the
runs.
compiler runs.
Yeah.
Yep. So these are design time analyzers. So I wanted to put an electric company logo here, but I don't know if anybody else would get the joke.
I would get it.
You would get it, would you? I thought you... Okay, so in .NET 6, I mentioned that this is on by default. If you have a project that was created before that, it won't be on. You need to turn it on if you want to do this. I recommend you always do this, unless it's an existing code base, in which case you have decisions to make. But if it's for new code, for whatever reason you're not using .NET 6, here's how you turn it on. It's this one setting in the CSproj file. And there are 4 values you can put in here. I recommend you only consider enable or disable, unless you have good reasons and an existing code base where you want to kind of ease your way into this or do what you can without having to go and refactor a ton of stuff.
How about .NET 7?
Yeah.
So I just...
If it's omitted and you're targeting 7,
it's still okay.
Yeah.
So I mentioned there are 4 settings, but the 4 settings are a little bit, I'd say, convoluted, because they're managing two states on these 2 settings, but it's not 4 to 4. There's a table. So if you want, you can go look those up. I might even have a slide here for it. But there are 2 things that the setting manipulates: the annotation context and the warning context. So as I've put in here, one determines the... Oh, man. Do you want to just grab it off of my... Thanks. I thought I had more time. Not like this. Not like this. So one determines the compiler behavior, and one determines the warning emissions. And it's probably not useful to try and separate those 2 in your brain. Just turn them both on with the enable setting. So
we all turn the warnings tab off anyway, so who cares?
Yeah, right. Well, I don't like the squigglies in my code. It messes with my eyes, you know. So here I have the 4 options and just the smallest description. So enable means that you allow null references, and that means that it will start giving you hints and warnings about violations. So disable is the old way. It just the way it's always been. If you have a reason to not allow that, cool. So if you need to look into those other 2, go ahead and do that, but hopefully you won't need them. If you need them, you'll need them on an existing code base. So here's just a screenshot of the learn.microsoft.com documentation for all of this.
Your slide was a lot cleaner.
Yeah. This one has more information on it. If you really want to separate the annotation context from the warnings context, this gives you the information about what those things do and mean. But I haven't needed it. I hope you don't need it. If you do, go look it up on this website. There's a link on the last slide. This is something I didn't know. There are override directives, and I've never had to use them until I did this presentation, and I found one of them useful. So let's talk about
For a single
that.
file, right? This goes in
This
a single file?
this is for for a single file down until you have a directive to counter it.
Okay,
So I just put one of
on and off.
Yeah, so I found that on LinkPad on my laptop, Nullable Reference Types was enabled, and I never did anything to do that. I just noticed it as I'm using it. So I went to go take screenshots of this while I was doing the presentation on my home machine, and I wasn't doing it. It's not enabled. And I Googled, and I fiddled, and I tweaked, and I couldn't figure out a way to turn it on. I thought, well, I want to take screenshots of this with the squiggles. So anyway, I determined that I can put on this nullable enable right in the code, and it'll do it. So that's at least one case where I found that to be useful. And if you have an existing code base, maybe that's more useful. So you can say, here's new code and here's old code. I'm going to enable this for new code and disable it for old code. That might still get messy, but it's good to know that it's there and you can make choices. I mentioned this earlier in the slides there. I don't know much about this, but it was in the docs and I encountered it and I thought I'd better throw it in there.
I'm surprised you didn't put a picture of the game Pitfall.
I just ran out of time. I had
The other reference.
yeah. So
Alligators.
yeah. Arrays and structs that contain elements or members that are nullable references, or that can contain null references, and cause you problems because they won't generate warnings. I'm not really sure why that is, and there's not a lot of information on this bit, but just bear that in mind. If you really need that null reference safety, and you're working with an array or a struct that has members or elements, those might not be checked. So go look into that. So let's look at what you do in the code. We have these null operators, and I swear I'm missing one, but I couldn't think of it, and I couldn't find one. So we're going to talk about all three of these. And there are a multitude of scenarios where you'll use any given one, except the last one. There are a lot of scenarios where you will be tempted to use the last one and shouldn't. So the first is the null coalescing operator. You can see it on the second to last line with the double question mark. And for those who don't know, what that's going to do is it's kind of an if then else. If the first operand is null, then it's going to return the second operand. Otherwise, it's going to return the first operand.
And you can use that as many times as you want. You can have like 4 values all null coalesced in a row.
And so I find this useful to use. And you would be getting hints and warnings about this, or runtime errors. You wouldn't probably get hints and warnings, but you get runtime errors about this before we ever had the nullable reference types. And so this has been around since C# 5? I'm not sure. It's been a long time that's been there. So you can see in this one, I assign null to h1. We could pretend that it was just uninitialized and it would be null, and then I can check it when I make the resolution on the second one and assign it to h2 before calling it. The null conditional operator is kind of like that, but it can be done inline. And this is probably not a great example because I wish I'd used this example for another slide I have on this, but it works. So on that last line, we make an assignment to the talker property, but imagine for a moment that we didn't, that wasn't in the constructor, or there was no constructor. If someone were to invoke the sayHello method and talker had not been initialized, it would be null, and we would get a runtime error, which is a null reference exception. So we can use the question dot on the, I wish there were line numbers here. Inside the sayHello method, it says talker question dot invoke. So right here, this is going to prevent our null reference exception because it's going to say, is talker null? If so, return null and do nothing. If it's not null, then continue to resolve this member.
So it's basically a if talker not null.
Yes.
Another line of code.
Yep.
Yep.
That's exactly what it translates to.
So it's a lot like the null coalescing operator, but instead of
Returning a value.
an evaluation,
lets you do
it's
something.
on the dot operator. So The third one is the null forgiveness operator, and I've seen it written null forgiving operator. I don't think that's quite correct. I think it's null forgiveness operator, but you'll hear it either way. No big deal. So I struggled with examples for this because hopefully you're never using it. But this really is an example of when you'd be tempted to and how to not, and the problems that you'll run into, rather than a how to use it type of slide. So if I have a class on the left, which is called some class from a third-party library, which I cannot change, and you have a set of properties in there of types that are not nullable reference types. And this is a bad example too, because string is the exception, and it's kind of half a value type. But let's pretend that those were, for the sake of brevity, that those were class types or something like that. But we've run into this with strings as well. That's probably why I did it in my brain. So then I've got this main method on the right that does something with that class. And you can see right here I've got an instance, and I set the property of name, and then I call the instance. That's all fine as long as I'm instantiating that. And this method doesn't try to use the gender property, for example. It only uses the name property. But if I omit this for whatever reason, I'm going to have a null reference exception. Now this code really doesn't know the difference, except if I were to assign this, if this were a class type, its default value would be null, and then I'd have a real problem. And it could tell me then that I'm going to have an issue. I'd get a squiggle here, and I'd be tempted to use the null forgiveness operator. So the solution here is to initialize everything so that you don't have this problem. And then when I set the instance name to whatever I want and call it, I won't run into that problem. The null forgiving operator is, I've got a different slide for that. They're a little bit out of order that way. So here I say how to fix and avoid the warnings, and I've got a list here. And I say, notice that use null forgiveness is not on the list of how to resolve these issues. So use the no coalescing operator, which we've talked about. I have a slide for use if checks for null. Initialize all identifiers to non-null values up front, which is what I was doing on the previous slide. Change types to nullable types if they must be assigned a null value. And this is really probably the best solution if you're tempted to use a null forgiving operator. If you're using a null forgiveness operator, the problem really is that you're saying you know better than the compiler, and it's not true. The compiler knows that this is possibly a null value, and you may know that it's not a null value. But saying that please forgive me, I know better than you, is not the right approach. It may actually work, but the way that you got there shouldn't be the way that you did it. You should have a nullable type, or you should have some indication to the compiler that this wasn't going to happen. And there are ways to do that. So the second one up here is use if checks for null. That will avoid that, and we'll show that. The non-conditional operator can chain dereferences. I have a slide for that. And the null conditional invoke, which we saw just a moment ago. I have another slide for that, I think. So the null coalescing operator, you can see over here that I'm using it for a property that is declared nullable. So the problem with this slide is console.writeLine is really forgiving. It'll take any object, even if it's null, and it won't have a cow about it. But in a normal circumstance, if I'm trying to dereference name, I should do it this way. The if check for null, here is h1 is null, and it's a nullable reference type. And I try to invoke a member on it. This is going to have a runtime error. There's no doubt about it. But I get a squiggle about it to tell me. So if I were to put the null forgiving operator here, because I know better, I'm really still going to get that error, but the compiler stops complaining about it. So it's possible the compiler does know better than you. And if I'm not sure, I can code this. And I can say in an if block, if h1 is null, then I'm not going to execute this code. You can see the comments there. It points out that the line above has two problems. One, the compiler is giving you a null check warning, and two, you will have a runtime error. So you really have two problems. The if block, of course, will solve the runtime problem because that's just code. It's an imperative that will not encounter the error. But you see that the squiggle went away because the analyzer also recognizes this to be a solution. Here's how I would initialize the nullable up front. So as long as I have this nullable and I assign it a non-nullable value, I'm not going to have a squiggle here where I reference it. because the compiler recognizes that it has a value.
Okay.
The null conditional operator for chaining. So here's how you use the null conditional operator. So you can see here I have a dot child dot value. So this guy is null, and I get a squiggle. But if I use the question dot all the way down to the end, I won't have that problem. He'll just not run. And if this is the being assigned to something, it'll be assigned the default value, which is probably null.
So this will return null, will end up being null if everything else is null.
Yep.
Yes. Yep. Of course, in this example, I've got both of them there, and this one will preclude this from running, but if you had just one or the other.
You'll notice that it's not nullable though, so I would have thought you would have gotten a warning. This will return null. There's no question mark at the end of that variable declaration.
It's
Or is it inferring it?
a var. It can infer that type.
Okay. So it's inferring that it's a
So
null.
That it's a
var
nullable
infer
type.
nullable.
Yes.
That's interesting.
Yep.
Cool.
Okay. I had a slide about this, but I said I had another one specifically for this. Probably shouldn't have had both. But if you would normally have a function that you want to invoke, you used to have to say my variable equals this function, and then if my variable, just to capture it, and then if my variable is not null, then call the function. This is a lot easier because we don't have to capture and then check. The dot invoke will do the run, and the question dot will do the check. So talker question dot invoke will never throw a runtime error if talker is null.
Isn't it the hello world string though that's now nullable?
It is according to his action type, yeah.
Yeah.
Sorry, say that again.
You
You
put
have-
the nullable on the string in action.
The string is nullable, but the action is also nullable. It can be assigned to null. I should have made them both nullable. That's an error on my part.
Okay. It's clear.
Yep. And then we talked about strings. But if you have a string and you're having issues with it, instead of using the null forgiveness operator or assigning it null, because it really probably should never be null, you can assign it an empty string. And that is a more proper default for an uninitialized string. If you really need to have a null value on it, maybe that's okay. There's purpose to that. But if you're considering the null forgiveness operator, that's not the scenario where you would want to do that. All right. Here's the link to the whole page that has all this crapola on it. Just the one link. It's all there. Thanks.